Good morning, my dear students. So this slide shows the last session lecture, calculation of column end moments, which we have completed in the last session. So discussed in detail how you calculate column end moments. Okay, and the result is being plotted with these arrows that you see it here. So this red colored arrows, that they show the column end moments, which is step 4. Right. After this, let's go to step 5, which is the last step of the calculations. So if you go back and see all the steps involved in this cantilever method, where we have started with two assumptions. The assumptions, if you start with, the step 1 will be column axial loads. So after you calculate column axial loads, the step 2 will be beam shear. Okay. Then step 3 will be beam end moments. Then step 4 will be column end moments. And once you get column end moments in step 4, then the last step and the last quantity will be column shear. Okay. Once you get column end moment, you are able to solve for column shear. That is this one. So column shear, how you get it? It's very simple. So you have column end moment with you. So that will be calculated with column shear into half of the story height. Right, and I have explained this, in the other method, that is portal method, how this will happen. So the same explanation will be applied here also. So when you want a moment value, right, shear multiplied by the distance, half of the story height. Let me show you in the diagram. So this is half of the column where the at the middle, okay, you have the imaginary hinge. Okay, so there you find the column shear to act. So this is column shear value, right? So here is the location where you have already calculated column end moment. So this moment is because of this force. So hence this height, nothing but half of the height, because this is midpoint. This is a midpoint. Okay. So half of this height multiplied by this force will give you this moment. That is what is written here. M is equal to force into distance. That means something like y. Okay. So this is how this calculation. But you, what you have to substitute here is m value, which you have already calculated in step 4. This is what you want. So the equation will simply become V is equal to moment divided by half of the column height. That is what is done here. Okay. So half of the column height multiplied by shear force is equal to moment. And now we have substituted m value and we have substituted half of the column height. This divided by this goes to the denominator, that will give you shear value, and that is this one. Okay, so likewise every column you have to calculate all the columns. You see, the if you name the columns AH, BG, CF, DE, all these are the upper story columns. Then middle story columns HI, GJ, F, K, and E, L, middle story columns. Similarly, the bottom story columns I, P, J, O, K, N, L, M. These are the bottom story columns. Okay. So for all these columns, you should find the shear force. This is the shear force, right? Okay. Why I have kept this direction? Because the moment is already has a direction of clockwise. So if you have to have the clockwise moment, the force should act to the left. Similarly, the other counterpart of the shear. Shear cannot exist in a single arrow, that you know, right? So to have this direction bottom end, you should have this arrow, right? Force acting, shear acting to the right. So this is the shear notation in column. Similarly, the other columns. Got it? So likewise, you should have all 12 columns shear values. That is how you calculate. It's very simple. This moment divided by this height, half of the column height. Okay, it's 5 meters here. So this will be this divided by 2.5. Then 4 meters height, which means 2 meters. So this divided by 2. The bottom story 3 meters, 1.5. So this divided by 1.5. So likewise for all columns we will do. So let us see top story columns. So as I said, 5 by 2 is 2.5. So this divided by 2.5, 2.036 is the shear force in column AH. Similarly, BG. So it is 5.985 is the shear force in column BG. Right, same way CF. Okay. So all these columns are having the same column height. That's why. So for all the cases, it is 5 by 2. So as now the moment is more in CF column, and that's why shear is also more. Right, going for the middle story. Let us see. Same here. Column FK is having the highest value of moment, hence the highest value of shear. Same here, as I said, it is 4 meters height. So 4 by 2 is 2 meters is the half of the column height, right? So 10.188 is the end moment, MHI, which is already found from step 4. By 2, this is the shear force. Same case here, divide by 2 will give you the shear force. So likewise, all the 4 columns in the middle story. Similarly, when you come to the bottom story, so bottom story is having 3 meters height columns. So 3 by 2, 1.5. Same here, the highest moment is having Kn column, and that divided by 1.5, the highest value of column shear. So all other columns. So for all the cases, it is 3 meters for bottom story columns. So 12 column shear values are to be calculated. So 40.408, 13.746, 27.08, all these are the column end moments calculated in step 4 divided by the half of the column height will give you all these column shear values. Okay. So this is the simplest calculation that you can make to arrive at all these step 5 values. Okay. So column shear calculation is much simple. Just column end moments which are calculated from step 4 are to be divided by the half of the column height. to get the shear value V. Okay, in all these columns VAH, VBG, VCF, and VTE. Likewise, all other columns. Okay, so with that, all five quantities we have calculated, starting from the column axial loads. This is the starting calculation. So let us see how that is to be represented in the diagram. So blue colored arrows, these are the column shear values that I have mentioned. So you can see your diagram should look like exactly like this. Okay, so this is what I said. This arrow is going to cause this moment. This arrow, this is going to cause this moment. So likewise, all other columns. Okay, as I said, this is the highest value. Similarly, this is the highest value. Similarly, this is the highest value for that particular story. And overall, if you see, this is the highest value of column shear. Okay. So column axial loads, step 1, step 2, beam shear, step 3, beam end moment, step 4, column end moment, and finally step 5, column shear. Okay, this diagram shows the complete solution of the frame taken. Okay, so carefully practice all these 5 steps, because this, when compared to portal method, this cantilever method involves little bit of step 1 involves some typical calculations like CG, locating CG of columns, and then applying assumption 2, which is nothing but the axial stress in column is proportional to its distance from the CG of all columns. Okay, that is the assumption 2 that is assumed for cantilever method. So this is the complete solution, and try to get this when you practice on a paper, right? Right. So let us see the other questions that are being appeared and try solve them. Practice them at your home. Okay, so that you get the confidence. So this is JNTUK May 19 appeared question. So what just go through the questions. Explain along with the assumptions the portal method for analyzing a building frame subjected to horizontal force by taking an example. So this you have to take an example. Just you assume some frame, some loads, then you just solve by portal method. That's it. Okay, and just write those two assumptions for the portal method, and then analyze the frame by taking your own example. So that gives you 7 marks. Similarly, so analyze the frame shown in figure for forces in top story by cantilever method. Only the top story, right? Assume that all the columns have equal area of cross section for the purpose of analysis. So don't go to the remaining part of the problem. Just top story. Whatever you calculate, what do you do? First, you locate CG of columns. That we will do that. Then apply the assumption 2. So you get column axial loads first. Okay, don't go for the bottom stories, just finish only the top story. So just work out the beam shear, then go for beam end moments, then go for column end moments, then go for column shear. That's it. Only work out the top story. Okay, as I said, only in top story. So top story columns and top story beams. So that's 3 plus 2, 5 members present. Okay, so problem is simplified, just 7 marks. Right, then 18 October has got cantilever method. So just take this frame and analyze by using cantilever method. Same way, you have to assume the CG of columns to calculate first, then assumptions, two assumptions. So point of contraflexure, imaginary point of contraflexure occurs at the midpoint of each member. Okay, then the assumption two, you have to locate CG of all columns and then apply assumption two that the axial stress, that means force by area, axial force by area, axial force divided by area. That means axial stress is proportional to the distance. Okay, distance from what? Distance from CG of all the columns. Okay, so that you have to apply and complete step one. Then step two. Okay, and then step three. Then step four. Then step five. This is how it flows, right? Okay. Similarly, the other one with cantilever method. Okay, so this is also cantilever method. That's all, right? With this approximate methods of unit 2 of your syllabus. So portal method we have completed, and then cantilever method we have completed. Sufficient examples and also the problems that you have to practice at home, right? So practice well with this unit, and then have enough confidence to attempt in the examination, right? Thank you so much.